Hey everybody, we're ready for chapter 8 and it's all about inequalities. So in the first section, we're going to talk about linear inequalities in one variable. So those are inequalities we have that we'll have one variable and we'll solve these pretty similar to what we solve linear equations. And then we're also going to graph inequalities in one variable. And so we'll go through some examples here. So we have 5a plus 3 is less than or equal to 6a. So we want to solve for a basically, and so just like in an equation, we're going to get all the a's on one side if we can. There aren't any squares or anything crazy going on, so we can just move all the a's to one side. I usually prefer to get the variable on the left with inequalities and work from there. So I'm going to subtract the 6a from both sides. Then I get negative a plus 3 is less than or equal to 0. And then I'm going to get the numbers on the other side. So the 3, I'm going to subtract the 3, so subtract 3 from both sides. And what do we get? We get negative a is less than or equal to negative 3. Okay? And then I would like the a to be positive. So I can either multiply or divide by negative 1. So if I divide by negative 1, let's say, I get a on this side and I get 3 on this side. One thing we have to remember with inequalities is when we multiply or divide both sides by a negative number, we have to flip the inequality sign. So that less than or equal to is going to become a greater than or equal to. And the only time we flip the inequality sign is if we multiply or divide by a negative. So we have a is greater than or equal to 3 then. And so there are a couple of picky things here. You might think, well, we're done, we're finished, but we're not actually. We have to write the solution set in interval notation. One big goal of this whole chapter, and this section particularly, is to get you used to interval notation. A lot of you have probably seen it before, but maybe you haven't, and maybe it wasn't used a lot when you were in high school. So interval notation, we're going to use some symbols to represent the solution set for this inequality. So we want to write all the numbers that are greater than or equal to 3, all the real numbers. And so your starting point then would be 3, right? That's the smallest number that would belong to this solution set. So I'm going to write a 3. Then we use a comma and give the largest number in the solution set. Well, anything bigger than 3 means we could go all the way to infinity. So we have 3 comma infinity. And then we have to use some symbols on each side of this solution set to tell us if those endpoints are included or not. If an endpoint is included, that means we have an equal to bar, right? So that means that 3 is included in this solution set. Then we're going to use a bracket with the 3. So we use a bracket. That bracket tells us that the 3 is included. Now infinity, since we can never actually get there, we're always going to use a parenthesis with infinity. So parenthesis means that's not really included. And the reason infinity is not included is you could think of it as we can never really reach infinity. We can approach infinity, but it's an arbitrary thing. We can never really get there, right? So this solution set, this is the interval notation, and what it tells us is every number from 3 to infinity is included in the solution set, and this bracket tells us 3 is also included. If this would have been strictly greater than, we would have used a parenthesis with the 3, which would tell us the 3 is not included. Now, I've given you a number line here to graph this on. If you have good interval notation, the good thing is the graph looks a lot like the interval notation. I'm going to put a 3 somewhere on the number line because we have to have that 3. That's important, right? So wherever you want to put the 3, maybe I'll put it right here. And we want everything bigger than that or equal to it. Well, this bracket that's in interval notation we can also use on the graph. We could put a bracket right at the 3. That tells me that the 3 is included, and then we can shade the rest of this on forever to the right. Now, one thing I like to do sometimes is to use a highlighter. Let me see if I have one. I do. I have a pink highlighter. So what I'm going to do, because it's a lot easier than scribbling ink, is I'm going to make a little highlighted with an arrow, right? So that tells me everything from 3 to infinity. Now on my lab they have some nice tools where you just shading tools, and they have the brackets available. Now if you back in high school you might have used a solid dot instead of the bracket. The solid dot is okay, and I think that's even an option on my lab, and if you like that better you can use that, but the interval notation will be required, and if you're going to use this interval notation, since the graph kind of matches what it looks like, you may as well use the same notation with your graph. Alright, so that's that one. Now let's look at the next one. It might not be a bad idea for you to try this one on your own. Pause the video and then you could check your work with mine. Alright, so we have 6 plus 3x is less than 4x plus 4. Again, I'm going to get all the variables on one side and the numbers on the other. So I'm going to subtract the 4x. And since I want to get all the numbers on the other side, I'm at this in the same step. I'm just going to subtract the 6 as well, so I can move it to the other side. So I'm going to kind of do 2 steps in one here. So 6's go away on this side. 3x minus 4x is a negative x. I have a less than, and we have a 4 minus 6, which is a negative 2. Alright, so we have kind of the same situation we had before. We have the negative x and we don't have a positive x, so we need to either multiply or divide both sides by negative 1. So I'm going to divide. When we do that, on the left we end up with just x. On the right we get a 2. What goes in between? Well, since we divided by a negative, we have to flip the inequality sign and make this x is greater than 2. So your interval notation. So 2 would be the smallest boundary point on this set, right? So I put a 2. And we go everything bigger than that, so I go up to infinity. Now this time there's not an equal to bar, which means I'm going to use a parenthesis with the 2. And with infinity we always use a parenthesis. So this is the interval notation, and what it represents is everything from 2 to infinity. And so on my number line somewhere I'll put a 2. I'm going to put a parenthesis with the 2 just like the interval notation. And I'm going to shade to the right. I'm going to use my highlighter just a little faster than scribbling in with ink. I put an arrow to show that it goes on forever. Alright, so that's the first couple examples. Let's do one more. Again, you might try this one on your own. Pause the video and see if you can do it. Alright, so now we're going to try to get all our p's on one side, right? So I'm going to subtract the 4p. Generally, I like to have the variables on the left because like for this one up here, if I had 2 is less than x, a lot of times people get this arrow wrong if they put the variable on the other side. Because we generally read left to right, don't we? If you put the variable on the right, you have to really read right to left in order to understand the graph better. But anyway, I'm subtracting 4p from both sides. And I want to get all my numbers on the other side, right? So I'm going to go ahead and subtract the 3 as well. And so what do I get? The 3's go away. I get p is less than or equal to 0, right? 0. Everything goes away there. So p is less than or equal to 0. Now, do we have to flip the sign? We don't, right? Because we never divided by a negative. In fact, we didn't have to divide by anything here. So we have p is less than or equal to 0. So 0 needs to be somewhere, but here we're less than or equal to, right? So the smallest number would actually be negative infinity because we can go as far as we want to less than 0. We always put the smaller number on the left in interval notation. Negative infinity is smaller than 0. We're going to go all the way to the left of 0. and we go up to 0, right? Now, with negative infinity, just like infinity, we're going to use a parenthesis because we can never really get there. And with 0, since there's an equal to bar, that means 0 is included, and we use a bracket to signify that inclusion. And so on my number line, I'm going to put a 0 somewhere, and this time I'm going to put the bracket at the 0 facing the same way as the interval notation, right? And we go and we want to shade to the left. Alright, so there is our graph for that one. That was a little different because we went to the left. Another point or quick tip, if you do get your variable on the left, which I would recommend, like we have in all three of these cases, we get all our variables on the left. The inequality sign, if you think of it as an arrow, it actually points the direction we have to shade. Notice this is pointing to the left, that's going to the left. Here we're pointing to the right, it's going to the right. Here we're pointing to the right, it's going to the right. So that's just another quick tip. Alright, so let's look at some that are a little more complicated. We're asked to solve and graph both of these. I didn't provide a number line, so we'll make our own, but these are a little more complicated, a little more operations to do, but we'll just take it a step at a time. We still don't have any variables squared or anything, so this is what we call a linear inequality. So we start to simplify. We probably try to simplify one side. Maybe we could distribute this -6 here, right? And so I'm going to write -6x minus 24 plus 1 greater than or equal to 9 minus 2x. We can combine some like terms on the left. -24 plus 1, we could do that, and that gives us -23. And then we get one that's in a form similar to the ones above, which aren't quite as bad. Again, I like to get all my variables on the left, so I'm going to add 2x to both sides. Get all my numbers on the right, so at the same time I'm going to add 23 to both sides. And see what we get. Well, -6x and 2x is -4x. And then we have, let's see, 9 plus 23. What is that? 32, right? 32. Alright, and now we need to either divide by -4 or multiply by -1/4, either one of those. So I'm going to divide by -4 in this case. -4's cancel here. We get x is, what do we have to do? Don't forget, right? We divided by a negative, so we have to flip the inequality sign. It's a real easy thing to forget. We want to make sure not to forget that. So x is less than or equal to, we flip the inequality sign, and we have a -8. Alright, so you might think, again, maybe in the past, you might have solved inequalities for someone, you might think we're done. But we're not actually done. We have to write the interval notation, and then we're also asked to graph in this case. So your interval notation, let's think about this. If we are going x is less than -8, we could go all the way to the left to -infinity, right? So maybe I'll write the answer to in the margin because I have a little more space over here. Interval notation, since we go left forever, -infinity, right? And then we go all the way up to -8. And we have to decide what symbols to use on each side. Well, again, with infinity or -infinity, we're always going to use a parenthesis because we can never really get there. And then with the -8, since we have an equal to bar, we can include -8, which means we use the bracket. Okay? So if there's an equal to bar, you're going to use a bracket with your number. If there's not an equal to bar, you're going to use parenthesis. So that's your interval notation, and then the graph. Well, let's make a little number line. We need a -8 somewhere, right? And we just use the same symbol, the bracket, going the same direction even. And we shade everything to the left because we're going to go all the way to -infinity. Negatives are on the left on a number line, positives are on the right. So your smaller numbers are left, larger numbers right. And again, with interval notation, you always want to check and make sure your smaller value is on the left here. If I would have put -8 comma negative infinity, that would have been incorrect, because we're going to read left to right with interval notation, so we put our smaller number on the left. This means everything from negative infinity to -8 with the -8 included. Alright, let's look at another one. Alright, so first thing I notice about this one is there are fractions, right? And I don't really like fractions if I can avoid them. So the first thing I'm going to do is eliminate the fractions. Just like we did with equations, we can multiply both sides by a common denominator, the least common denominator for these three denominators. 3 and 2 both go into 6, so I think that will work. Let's multiply both sides by 6. Multiply this side by 6, multiply this side by 6, and we should get a lot of things canceling out. So we really have two terms here, the -1/2 times r minus 5 and the plus 1/3. So I'm going to multiply 6 times the -1/2 and 6 times the 1/3. Well, 6 times -1/2 gives me a -3. We have -3 times r minus 5. 6 times 1/3 gives me 2. On this side of the inequality, we have 1/3 times 5 minus r, so we can multiply the 6 times the 1/3. That gives me a 2 times 5 minus r. Alright, so now we have an inequality with no fractions, which makes it a little easier to work with. So just like before, we're going to distribute here. We have -3r plus 15 and then plus 2. Over here we get a 10 minus 2r. We can combine like terms on the left. We can combine our whole numbers here. 15 and 2 is 17, so we get -3r plus 17 is less than 10 minus 2r. So now we want to get all our r's on one side. I'm going to add 2r to both sides. I like to put my variables on the left again. And then we're going to subtract 17 and see what we get. So let's see. -3r plus 2r, that would be a -r. I'll put that over here where I have room. And I'll put a line down here so we don't get confused. There we go. And then on the right, so the 17's cancel, right? But on the right, we have 10 minus 17, which is a -7. Now, we need to either multiply or divide by -1. I'll divide by -1. When I do that, we don't forget, flip the inequality sign. We get r is greater than 7. Okay. So your number line, let's see, we may make a little short number line here, but still accomplish the same thing. We have a 7 somewhere in that number line. Oh, we got to do interval notation, right? So interval notation, r is greater than 7. What does that tell us? Well, we can go anywhere past 7. We can go way off to infinity, right? And 7 would be the smallest number as a boundary anyway. So we have 7 comma infinity. In this case, since there's no equal to bar, we have a parenthesis with the 7 and a parenthesis with the infinity, because we can never get to infinity. So this is my interval notation. That's my answer, really. As a graph, we're going to just mimic the interval notation. We have a parenthesis, and I'm going to shade with my little highlighter everything to the right. Alright, so we have interval notation, we have our graph, all is good. Now we have two more examples here to look at, right? These are what we call double inequalities. So notice we have two inequality symbols, right? Two inequality symbols. To solve a double inequality, we need to get the variable by itself in the middle. It's almost solving like solving an equation with three sides. So we have three parts to this inequality: the left side, the right side, and the middle. Okay. So we're going to do operations to the middle to try to get the x by itself. And whatever we do to the middle, we have to do to both sides as well. So to get x by itself in the middle, I'm going to subtract 3. but I have to subtract 3 from all 3 parts of this inequality. So on the left here we get a 4, in the middle we get a 2x, and on the right we get a 10. So still have double inequality. We're always going to have double inequality until the end, and then we can write interval notation. But so x is closer to being by itself, but we still need to divide by 2, right? Or you could multiply by 1/2 if you like. So I'm going to divide by 2 since they're all divisible by 2. So we get a 2. Do we have to flip the inequality signs? Hopefully you said no, because we didn't divide by a negative here, we divided by a positive, right? The only time you would have to flip the inequality sign is if you divide or multiply by a negative number. Since we didn't do that, the inequality signs stay the same. 2 is less than x is less than or equal to 5. Alright, so here is our solution, but we need to write it in interval notation. Okay, so interval notation, we're going to use these two numbers, which sometimes this is actually easier in interval notation. We have a 2 and a 5, and we have to figure out what symbols to use. Well, if you just look at the first half of this, it says really 2 is less than x, right? Or x is greater than 2. There's no equal to bar with the 2, which means the 2 is not included. We use a parenthesis. But there is an equal to bar with the 5, which means the 5 is included, and we use a bracket. Okay, so this notation says everything from 2 to 5 with 5 included. 2 is not included. If we want to graph this one, right? So let's graph it. Maybe I'll do this to the left here. All right, let's get my ugly mug out of the way. All right, so 2 and 5. We need to put both of those numbers somewhere on the number line, right? A 2 and a 5. Just like the interval notation, we put a parenthesis with the 2, a bracket with the 5, and we're going to shade everything in between. Pretty easy, right? So let's look at one more of these. We'll be done with this page. We want to get x by itself in the middle, so I'm going to add 2 to all 3 parts to begin with. And so that gives me a negative 15 is less than negative 3x, which is less than negative 9. Then we need to either divide by negative 3 or multiply by negative 1/3. I'm going to divide by negative 3. When we do that, do we have to flip the inequality signs? Yes, we do, right? We divided by a negative. So change this to greater than, change this to greater than. In the middle we get our x, over here we get a 5, and over here we get a 3. Now if we did not change the inequality signs, this would be completely false, right? Because it would say 5 is less than something, which is less than 3, but 5 is not less than 3. So flipping the inequality signs actually keeps things correct. It's not just some cruel thing we throw in to make you do. It keeps things factual. So, all right. Now, let's see, what do we do with this? Well, one thing that I don't like really, a lot of people will look at this and they'll start to write their interval notation and they'll say 5, 3, because 5's on the left. Well, that would be incorrect because you have to have the smaller number on the left. So when you have a situation like this with a double inequality, I like to have less than signs, and we can accomplish that by just reversing everything. So if we read right to left, 3 is less than x is less than 5, and rewrite that, 3 is less than x is less than 5, then the order will match your interval notation because the smaller number is now on the left. And so your interval notation, we have a 3, 5. Since we don't have equal to bars with either of those, we have parentheses with both. So that's your interval notation, and your graph is pretty simple then. We need a 3 somewhere and a 5 somewhere, parentheses with both, and we shade in the middle, right? Alrighty. So that's first page of the 8.1 notes, and we'll continue on the next page.